Welcome to 4+arctanx. Today we're gonna do the integral of sec² of pi over 4 plus inverse tangent x. Whoa, this looks so indeterminate, man. You have a sec² and then inside you have another function, inverse tangent of x. This cannot be integrated. But let me tell you, this is equal to 2 times x² plus 1 over x minus 1 square dx. You will be wondering, why? Why is that true? And let me show you. Let me give you a proof. Here, I'm going to change this in terms of secant. And first, we need to know about the tangent formula. Tangent, we know that tangent of a plus b, a and b are our angle, is equal to, you know the formula is tangent a plus tangent b over 1 minus tangent a times tangent b, right? And here, we're gonna find the formula of the sum of two angles, and we're gonna and a, we often use big letters, they stand for angles here, and then here we're gonna let our a to be our inverse tangent of a and then here small letter a, and then b is equal to inverse tangent of b here, and we always use a and b as the length units, and then here this will be equal to tangent of inverse tangent a plus inverse tangent b will be equal to what? Tangent of tangent small letter of a, and then keep doing plus inverse tangent of b, and then 1 minus tangent of inverse tangent of a times tangent of inverse tangent of b. You see, this and this, they cancel each other out because the tangent, inverse tangent, and tangent, they are the inverse, so they just cancel each other out. You can see, and then you're gonna take the inverse tangent on both sides, so you will get inverse tangent a plus inverse tangent b will be equal to small letter a plus b over 1 minus ab. This is not yet, we're gonna take an inverse tangent here. This is really cool, you see. So our formula is inverse tangent a plus inverse tangent b will be equal to inverse tangent of a plus b over 1 minus ab, right? Here is the deal. When a is equal to 1, and then our b let it to be another variable, and let it to be x, you see what happened? You see this, the right hand side. Let me do the right hand side first. The right hand side will be equal to inverse tangent of x1 plus x over 1 minus 1 times x. And the fun part, you see, the fun part, this a matches the 1, and we have another 1 here, and then the a matches the a, and then the x matches the b, so we can change it to inverse tangent of this 1 plus inverse tangent of x. And finally, you get inverse tangent of 1, you get pi over 4 plus inverse tangent of x. You see, we almost do that. So here's the deal. Here is the deal. So this one will be equal to this one, and then we're gonna take a tangent on one side. You will see what happens. Take a tangent on one side. So let me just do it. 1 plus x over 1 minus 1 times x is just 1 minus x will be equal to tangent of pi over 4 plus inverse tangent of x. Oh, this is really cool, right? So this is the conjugate formula, and we also have a formula. Just put x is equal to negative x, so you can get 1 minus x is equal over 1 plus x is equal to tangent of pi over 4, and then put negative x, and then because inverse tangent is a r function, so you can put a negative outside, so you can get pi over 4 inverse tangent of x. And here is the conjugate formula. I've inverse, and this is really cool, right? But this time we're gonna use this formula, because you see the inside is plus inverse tangent x. So today we're gonna use this, and here is the deal. 1 plus x, the conjugate formula, 1 plus x over 1 minus x is equal to tangent of pi over 4 plus the inverse tangent of x. And here, how can we get a secant here? First, we gotta square both sides. Square the tangent, you get tangent square, and the tangent square you can change it to secant square minus 1, right? So, and then you're gonna add 1 on one side, so you can get that. So, let's just do this. Let me just square both sides. You see, square the inside, you get 1 plus 2x plus x squared over 1 minus 2x plus x squared will be equal to tangent square of pi over 4 plus inverse tangent of x. And here's the deal. We want the terms in terms of secant square here. We already get the inside, we need to get a secant. What shall we do? We can change it into secant square, right? Secant square of pi over 4 plus inverse tangent of x, and then minus 1 will be equal to that, but here is the identity. The left hand side get this over 1 minus 2x plus x squared, and then add 1 on one side, so you can get a secant in terms of secant square here. So let me just write the subject at. On the left hand side, secant square of pi over 4 plus inverse tangent x will be equal to, we want to get the same denominator, just add 1 and then multiply by that. But so you can get 1 plus 2x plus x squared plus 1 minus 2x plus x squared. And ladies and gentlemen, you see, and here 2x and negative 2x, they cancel each other out. So finally you get 2 plus 2x squared. Let me just factor it. Just 2 times x squared plus 1. And this is just equal to that. Right? So finally, secant square of pi over 4 plus inverse tangent of x is equal to 2 times x squared plus 1 over parentheses x minus 1 square. Whoa, this is really cool. And you can also get you can also use this and then divide it by 1 on one side. You can get cotangent square. And then cotangent square, you can change it to cosecant square minus 1. And you can also get a form in terms of the cosecant square. And this is really cool. Also, you can get cotangent square. And the cosecant, you can just divide it by 1 on one side. You can also get a form of sine square. And this is really cool here. And here, we just need to integrate it. And here, how can we integrate? First, we just need to explain it. To put it outside integral, where is a constant, and then x squared plus 1 divided by x squared minus 2x plus 1 dx. And here, I'm going to use our long division, just divided x squared. Let me just add a 0x to help us out, and then plus 1, and then divided by x squared minus 2x plus 1, and then this time that you get the x squared, right? And then this time that you get negative 2x, this time that get positive 1, and then you're gonna subtract it. You get 0 here, and then you get a positive 2x. So here, you're gonna integrate, and this is equal to 1 plus the integral of 1 plus 2x over x squared minus 2x plus 1 dx. This one is really easy. Integrate 1, you get x. But how can we integrate 2x over x squared minus 2x plus 1? Here is the deal. Just we want to use the natural law, and then if you differentiate ln of x squared minus 2x plus 1, you will get x squared minus 2x plus 1, and then because our chain will multiply by the derivative of this, you get 2x minus 2. So if we split it to 2 integrals, that will be very amazing. So let me just do that. So minus 2 and add 2 on both sides. And here you will get distribute the, don't distribute yet, just 2 times x plus, or up to you. Also, let me just finish the integral right here, just 2x, and then plus 2 multiplied by inside the integral of 2x minus 2 over x squared minus 2x plus 1 dx. And then plus the integral of 2 over x squared minus 2x plus 1 dx. This is really cool. And here you just get 2x and then plus, this just natural log, you will get 2 times a natural log, and then here we just need to use a parenthesis here. And then here we're gonna multiply by 2, you get 4, right? Add 4 times the integral of this, and then here we just need to get back to that. You get x minus 1 squared dx. And finally, here is, you just need to factor it once again. You get 2x. And here we just need a parenthesis here, because if this one it can be complete square, so it's always gonna be positive. So don't worry, just put a parenthesis here. And then here 2x, let me just show the step here. X plus 1 minus 1, x minus 1 here, x minus 1 square that, plus, and here 1 over x squared situation, that u is equal to that, du will be equal to that, right? Equal to dx. So overall you will get negative 4, and then multiply by 1 over x plus 1 square. And ladies and gentlemen, here we're gonna put a 2 outside the L1 because of the log property. And here, ladies and gentlemen, the integral of secant square of pi over 4 plus inverse tangent x will be equal to 2x, and then 2 times 2 you get 4 times L1. And here, I think we need to use the absolute value here, because we put a 2 outside. Here, I think we should put the absolute value by 1 over x minus 1. to the absolute value x minus 1 minus 4 over x minus 1 plus c, and that's our answers of this integral. And let me just show the step: x squared minus 2x plus 1. And that's it. This is really cool, right?